Today, we are going to journey to the most massive and breathtaking volcano in our entire solar system, a geological behemoth that rewrites everything we thought we knew about how planets shape their surfaces. Its name is Olympus Mons, and it is not just a mountain, it is a monument to the raw, unbridled power of planetary volcanism, a silent giant that has stood watch over the Martian surface for billions of years. Let us begin our voyage to this alien titan. To truly grasp the scale of Olympus Mons, we must first compare it to the tallest peaks we know here on Earth. Mount Everest, the crown of our planet, rises 8.8 kilometers above sea level, a height that challenges even the most experienced climbers. Now, picture a volcano that reaches nearly 21.9 kilometers above the Martian datum, more than 2.5 times the height of Everest. If you could stand at the base of Olympus Mons and look upward, the summit would be so far above you that it would often be hidden by the thin Martian atmosphere, shrouded in wispy water ice clouds that drift across its peak. This is not just a tall mountain. It is a vertical leap into the edge of space. And height is only part of the story. Olympus Mons stretches about 600 kilometers across its base, creating a footprint roughly the size of Italy or the state of Arizona. Its total surface area tops 300,000 square kilometers, making it far larger than any volcanic structure on Earth. When you fly over it in a spacecraft, you cannot even see the entire volcano in one field of view. It is that vast. What kind of volcano is this cosmic giant? Olympus Mons is a classic shield volcano, a type named for its broad, gently sloping shape that resembles a warrior's shield lying on the ground. On Earth, the best examples of shield volcanoes are the Hawaiian Islands, formed by hot fluid basalt lava that flows easily across the surface and builds up wide, low-angle slopes over time. But while Mauna Loa, Earth's largest active shield volcano, stands about 9 kilometers tall from its base on the ocean floor and spans 120 kilometers wide, Olympus Mons is nearly 100 times greater in volume. Its slopes average just 4 to 5 degrees, so gradual that if you were standing on its flanks, you would barely notice you were climbing upward. The horizon would stretch flat before you, hiding the true steepness of this immense structure. This gentle slope is one of the many clues that reveal how this supervolcano was built. The formation of Olympus Mons is a story written in lava and time, driven by three unique factors that make Mars fundamentally different from Earth: the absence of plate tectonics, much weaker surface gravity, and extremely slow erosion. Let us break this down step by step, because each element is essential to understanding how Mars grew such an enormous volcano. First, Earth's outer shell is split into dozens of rigid tectonic plates that constantly move, collide, and slide under one another. Our volcanoes often form long chains, like the Hawaiian Islands or the Pacific Ring of Fire, because the plate moves over a stationary hotspot deep in the mantle. The hotspot keeps erupting, but the plate carries each new volcano away, so no single volcano can grow indefinitely. Mars is a completely different story. It is a one-plate planet. Its crust is a single solid shell that never moves. This means the mantle hotspot that feeds Olympus Mons has stayed in exactly the same place for billions of years. Lava has erupted from the same vent, continuously, layer upon layer, flow after flow, building the volcano higher and wider without interruption. There was no geological force to stop its growth, no plate movement to carry it away from its heat source. Second, Mars has only about 38% of Earth's surface gravity. This low gravity changes everything for volcanic formation. On Earth, gravity places a strict limit on how tall a mountain can grow. Beyond a certain height, the rock at the base cannot support the weight above it and collapses. On Mars, the weaker gravitational pull means the crust can support far more mass without breaking. The theoretical height limit for mountains on Mars is well over 25 kilometers, and Olympus Mons sits comfortably within that range at nearly 22 kilometers. The low gravity also allows low viscosity basalt lava to flow much farther across the surface before cooling and solidifying. Each lava flow can stretch for hundreds of kilometers, creating the incredibly broad base we see today. Third, Mars has almost no water, almost no atmosphere, and almost no erosion. On Earth, wind, rain, ice, and rivers wear down mountains over millions of years, carving valleys and smoothing peaks. On Mars, the atmosphere is less than 1%, as dense as Earth's. There are no rivers, no oceans, and no glaciers to wear away the rock. The lava flows that formed Olympus Mons are preserved almost exactly as they were when they cooled billions of years ago. This perfect preservation lets scientists study the volcano's history, layer by layer, like reading a book written in stone. As we approach Olympus Mons from space, one of the most striking features jumps out: a massive steep cliff that wraps all the way around its base. Known as Olympus Roops, this escarpment reaches heights of up to 8 kilometers, in some places taller than Mount Everest itself. For decades, scientists debated how this cliff formed. Some thought it was the edge of a giant landslide. Others believed it was a fracture where the volcanic shield met the surrounding plains. Today, most planetary geologists agree it formed as the immense weight of the volcano caused the Martian crust to flex and crack, creating a sharp boundary between the volcano and the flat Amazonas planitia beyond. In some areas, younger lava flows have partially buried the cliff, proof that the volcano continued to erupt long after the cliff first formed. Near the base, there is also a deep moat-like depression that circles the volcano, a result of the crust bending under the volcano's enormous mass. This moat is another unique feature found nowhere else in the solar system, a visible sign of just how heavy this giant structure really is. At the very top of Olympus Mons lies its most fascinating feature, a complex caldera system that stretches 85 kilometers long and 60 kilometers wide. A caldera forms when a volcano's magma chamber empties after a massive eruption and the ground above collapses inward. What makes this caldera special is that it is not just one crater, it is 6 overlapping nested calderas, each created by a separate major collapse event. The oldest calderas are on the outer edges, while the youngest are near the center, telling a clear story of repeated volcanic activity over millions of years. The deepest part of the caldera is about 3.2 kilometers below the summit, deep enough to submerge the tallest skyscrapers on Earth. These calderas are the heart of Olympus Mons, the vents, where countless lava flows began their journey down the gentle slopes to build the giant we see today. NASA's Mars Reconnaissance Orbiter, with its high-res camera, has captured stunningly detailed images of these calderas, revealing smooth lava floors, tiny collapse pits, and even dust avalanches that streak down their walls. In 2010, high-res photographed a fresh dust avalanche on the volcano's flank, triggered by a small meteor impact, proving that even this ancient giant is still shaped by small ongoing changes in the Martian surface. Our first good look at Olympus Mons came from NASA's Viking Orbiters in the late 1970s. Before that, astronomers had only seen a bright, fuzzy spot on Mars' surface, named for the mythical home of the Greek gods. The Viking missions sent back the first clear, detailed images, shocking scientists with the volcano's impossible size. For the first time, humanity saw a geological structure that defied all Earth-based expectations. Since then, a fleet of spacecraft has studied Olympus Mons. The Mars Global Surveyor mapped its height with laser altimetry. The Mars Odyssey Orbiter studied its mineral composition. The Mars Reconnaissance Orbiter captured ultra-high-resolution images. And even rovers, like Curiosity and Perseverance, have studied distant views of the volcano from the Martian surface. These missions have taught us that Olympus Mons is one of the youngest large volcanoes on Mars, forming in the early Amazonian epoch. Its most recent eruptions likely happened just 25 million years ago, a blink of an eye in geological time. This means Olympus Mons might not be extinct. It could simply be dormant, waiting for the next time Mars' mantle stirs to life. How does Olympus Mons compare to other volcanoes across the solar system? Let us take a quick tour. Jupiter's moon Io is the most volcanically active body in the solar system, covered in hundreds of erupting volcanoes that spew sulfur and lava hundreds of kilometers into space. But Io's volcanoes are small, steep, and short-lived, nothing like the slow, massive shield volcano of Mars. Venus has many volcanoes, including large shield structures, but none reach the height or width of Olympus Mons. Earth's volcanoes are limited by plate tectonics and gravity, so they can never grow to Martian scales. Even the largest asteroids and dwarf planets have no volcanic activity to compare. This makes Olympus Mons truly one of a kind, a singular masterpiece of planetary geology that exists only because Mars is built differently from every other rocky world in our solar system. Standing in the shadow of Olympus Mons, we cannot help but feel a deep sense of awe and humility. This volcano is more than just a scientific curiosity. It is a window into the inner workings of a planet. It tells us about Mars' hot, violent past, when its mantle was churning with molten rock, and its surface was reshaped by endless eruptions. It teaches us about the laws of physics and geology that govern every world, from the smallest asteroid to the largest gas giant. It reminds us that the solar system is full of extremes of landscapes that challenge our imagination and push the boundaries of what we think is possible. For future human explorers, Olympus Mons will be a landmark, a towering beacon on the Martian horizon. Someday, astronauts may walk its gentle slopes, collect samples of its ancient lava, and stand at the edge of its massive caldera, looking out over a landscape that no human has ever seen up close. As we wrap up our journey to the solar system's greatest volcano, let us take a moment to appreciate the wonder of cosmic exploration. Every time we point a telescope or launch a spacecraft toward another planet, we uncover new mysteries, new beauty, and new truths about the universe we call home. Olympus Mons is just one example of the incredible sights waiting for us beyond Earth's atmosphere. It is a reminder that the solar system is full of giants, both large and small, each with its own story to tell. Whether you are a lifelong space fan or just starting to look up at the stars, never lose that sense of wonder. The universe is vast, mysterious, and infinitely beautiful, and we are only just beginning to explore its most incredible corners. Please like, comment, share, and subscribe to the channel